Now, hey guys, for this video, we're gonna dive right in. Imagine this, we've all been in this situation. Flying over Fort Lauderdale, clear skies, beautiful view, sun is setting. In your TBM 930, there is nothing that could ruin your day from here on out. But before you even realize what happens, there is a thick layer of snow all over Fort Lauderdale. A storm has been kicking in to your left side, winds gusting. All in all, you forgot to turn on the pitted heat. What happens? Master Caution starts screaming. My Master Caution is screaming as well. Of course, the first thing that we're going to do is press that button to make it silence and then turn on pitted heat. So here you're flying, turbulence, your body is shaking, you're scared, and disaster strikes again. Your knee hits the fuel selector. It goes off, no fuel is running towards your engine. What happens then? Well, the master warning turns on, and the caution, of course, because the oil pressure is dropping. We're still airborne, and here we go. Airplane, airborne, in a storm, fuel is flowing, lights are off, and today we are going to be looking at how to wire up our own master warning and master caution buttons with some very generic buttons from AliExpress and a new update of the connector that makes this possible. Now, the buttons we are going to be using can be obtained from AliExpress. I'm guessing from a local retailer as well. Around here, there weren't really any good offers available, but they come at around €1. You can even find them for less. Make sure that you get the 5 volts, or if you get the 12 volts, you get an external power supply and apply the appropriate voltage towards the LED. Momentary or self-locking. I bought the self-locking because I thought that would be cool. Like, it goes in, goes out. But the downside is that for something like the master warning and master caution, you probably want a momentary one. These inlays can be changed. I just went to my printer, like an inkjet printer, printed out a master caution and master warning square, cut it out, put it in there. It doesn't really look high class, it looks kind of cheap, but I still need to find a way to make something that's on there and it looks good. Now, I've picked up a wide variety of colors, but they all work the same. Like I mentioned before, I accidentally bought the latching buttons, while the momentary ones would be better in this situation. If we would tear it apart, we would see that we get the top cover where we can put an inlay in. We have our little LED. I'm not quite sure if it's LED actually, but it's a little light. Now, if you take a look at our little switching mechanism, we can clearly see that this lever gets pressed down the moment that we press the button down, so when it's latched down. And this ensures that the ground can make contact with the pin that leads towards our board. There are multiple ways that you can wire this up. Most that you find at the product page where you can buy these things is a way to turn the light on the moment that you press the button, or the other way around, the light is on when you don't press the button. So it really integrates into the circuit of the button. Well, we are not going to use that approach because we want to separate the LED from the switch to ensure that we can turn on the LED from our board. And in the meantime, we can also register if the button is touched. And we don't want them to interfere with each other. So we don't want to press the button, then the LED goes on if there is a warning on. We always want to be able to trigger the warning. Now, safety first, kids. Always wear your safety goggles when you're working with side pliers. It's just a little hint because I saw some things flying towards my eyes multiple times. Our LED needs to be connected to ground and our button as well, because we're going to be using the internal pull-up resistors of our Arduino board to register if there's a touch. So we can also tie both together on our button itself to make things easier. And this leads us to just wire up 2 separate cables going from the 5 volt connection for our LED and one coming from the other pole of the button. Now, to really finish it off, we still need to add a wire to the ground pole so we can all just plug it into a breadboard. So if we got all soldered up, it's time to add our breadboard and Arduino in the mix. I'm going to be using Arduino Leonardo. So the first thing that we need is to connect the ground wire to our common ground line on the breadboard, and the other 2 just can be randomly placed at whatever pin you'd like. Now I'm going to move them up 1 row to the left, so we have the divider in the middle, and that is because the LED will be burned out the moment that we just pump 5 volts straight through it. So we need to add a little resistor in there. I'm going to be using a single resistor to bridge the gap of around 470 ohms in resistance. Besides the wire, we also want to wire up the button. I'm using pin 7 and 6 for both, respectively. This one doesn't need a resistor, so you can connect it directly towards the same line as the pin. Last but not least, connect the common ground of the board towards the common ground of the breadboard. And here we can see if we quickly take out the LED wire and put it in the 5 volts line, that the LED actually turns on and off. So a quick closer look, we can see that we got pin 7 and 6 used, we've got a common ground line, resistor in between to make sure that the LED keeps burning, and all comes together on the button itself. So I'm using an Arduino Leonardo. You could use any Arduino you'd like. If you want to use a Uno or a Mega or a Nano, it's important to remember to put a capacitor between the reset button and ground. This is to make sure that when it receives serial data, it doesn't reset itself. And just a little quirky thing that the board has to deal with. Now you can also use this on ESP32, Teensy, STM32, you name it, as long as it has serial over USB capabilities, it can use the connector. So here we go. First thing that we're going to do is add the connector as a library. So we do include bits and droids flight connector.h. This makes sure that we take all the code that's in the library and make it available to our sketch. So before you make the sketch, make sure to download it from the link in the description. So before you start coding, make sure to download the library from www.bitsandroids.com/downloads. It's also in the description down below. So once we've done that, we create an object of the library. And we just call it connector, so it's really clear what's going to happen. It's going to be bits and droids flight connector. Here we go. Now we've got one button wired up right at pin 6 and 7. 6 is the button and 7 is the LED. So we say byte. Oh, we can even do, let's do const byte because it's a constant. The byte doesn't change. That pin will always be on that pin. Now, why do we say const? It's because the pin where the button is connected doesn't change. It will always be at pin 6 and 7 unless you start switching it mid-operation. Then there could be a case that you don't have to be a constant, but in this case it never changes. So we say byte button, it's red, so we're going to go button warning, it's going to be 6, and const byte warning LED is going to be 7. So we've got two things and both have to do something different. The button is going to be coded up as a button which uses the internal pull-up resistors of the Arduino Leonardo. Most boards have internal pull-up resistors available. What does this do? It makes sure that if the button isn't pressed, that there is still a path to ground with some high resistance, usually around the 10K mark, to make sure that you don't get any erratic readings or that you don't get any messy, sloppy readings overall. So by adding a path to ground, it makes sure that it can constantly flow even if the button isn't closed. So we got to acknowledge that first. So we say button warning. And what kind of pin mode is it? It's going to be input underscore pull-up. So we enabled internal pull-up resistors. Now the LED, do we want to retrieve data from the LED? No. Do we want to use it as a button? Hell no. We want to use it as an output. So we also define that here. Warning LED, it's going to be 7. Oh, no, warning LED is going to be an output, sorry. There we go. So we defined the pins as an input, pull-up, and output. So now our board knows what these pins can do. It's not really a necessity except for the input pull-up. That is a necessity to make sure that those resistors are activated. Now to send data, we're going to be using the serial.begin 115200 because that's the same baud rate at which the connector works by default. Now what is the baud rate? It's the data transfer rate where it sends data towards your board or receives data from your board. You can alter this, but make sure that if you do so, the connector is also altered in the settings, so these baud rates match. Now, we don't need these comments. Put your setup code here, it speaks for itself. Put your main code here. So we need to check if the button is pressed, we want to do something. Now there is one downside of these buttons. They are momentary but latching. There are momentary variants out there. I'd recommend going with these because these are a bit easier to use. Now what do we mean by latching? Is that if we press the button, it stays closed. If we press it again, it opens. A little bit like a rocker switch or a toggle switch, except in a square format. Now why is that a problem? It's because like when the warning lights go off in the plane, it's not like our button just jumps out and we can press it. It will always be at the state that we've last put it. So if you press it, it will be lowered. If we press it again, it will be raised. And it won't change out of itself. Now, the in-game alarm might change by itself by turning on while we have it raised or lowered. And then we can come into a kind of situation where those states don't match. And we get all kind of weird behavior. So what we're going to do is just check if the current state, so if it's pressed or raised, is different from an old state. Because if it's different, we know that something has changed. So if it's high and low, low and high, those are all different scenarios. If it stays like this, we know nothing has changed. So for this, we're going to create a new byte, which is going to be old button state. Here we create a new byte. And why do we use bytes? It's because it's a very small size compared to an integer. It will save up lots of room on our Arduino board, which we can use for all kinds of stuff. So here we did byte. We say cur from current, or we just say current, why not? Current button state is digital read button warning. Now what does this do? It reads the button warning signal on pin, what did we say, 6. Now if it's low, we know that it's lowered, and if it's high, we know that it's raised, the button. Kind of makes sense if I say it like that out loud. Low and high in the backend, it gets kind of converted to a 0 or a 1, which we're going to be using to check if the states differ. So now we can say if current button state is not equal to the old button state, we do something. Now, once again, take this as a starting point. If we move something, something changes. But we have to make sure that the next check is going to be against this new state, or else you will always be checking against your starting state. So we change it. Okay, it's different. Then we change it back. Now it's the same because we never checked against the new state. Now we change it back. Now it changes. So it only changes on certain triggers. Now to circumvent that, we're going to be using the old button state. We're going to be setting the old button state, sorry, to the current button state. Here we go. Now, why didn't I start with logic? It's because there are these little things that get overlooked quite easily. And by just making sure that once you create that if statement and you put everything in that has to be in there for it to work properly, it makes sure that you have less errors in the long end. You can never avoid having any errors, but at least it reduces the risk. Now our logic is still going to be on top of this, but at least we now already have this old button state. It's going to be the new current button state to avoid having to check against the same state all the time. What were we going to do? We were going to send the command, and it's a red light, so I want to send the master warning. Send master warning. Now if you just want to send the command, this is it. That's all you need. There is a little downside that if you press it, there's also always a kind of bounce. It doesn't immediately close. It goes a little bit like close, open, open, close, whatever way around you want to see it, you want to look at it. So we could do two things. One could be to add a delay, and it's going to be a hefty one because it's quite a long press down, which works. there is a point to be made against this. Now, why is that the case? It's because it freezes up a CPU completely. It doesn't execute any other tasks until that time has passed. Now, if you don't want to use a delay, so you don't want to freeze up your entire code, we could also make a timer. Now, how did I do this? I created a millisecond since the start of the press, and I've noticed that I've made a typo. Is it possible to actually do this? Oh, okay, we just do it by hand. Millis with double L for milliseconds. Here we go, here we go, here we go. So now we've got two variables, the milliseconds since the start of the press, which I set to 0 by default, and the milliseconds since the press has started. But I just call it since press, but it's since the press has started. Now, if the milli started press is equal to 0, we want to set the starting time of the start press at the current milliseconds that the board is active. Now, if we do milliseconds since the press, it's going to be the current milliseconds that the board is active minus the milliseconds of the start. So if we deduct those from each other, we know how many milliseconds have passed since we started the press. And since the start of the press isn't 0 at this point, because we set it to the current milliseconds that the board is active, this won't be executed again. We start a new loop. This is going to be updated, and only if it's going to be bigger than 250 milliseconds, so it's actually kind of like a delay, we're going to send the master warning, and we're going to set the start back to 0. Because if it's back to 0, we're going to check, okay, if the current state is not equal to the old state, etc. So how does that look in the serial monitor? Here we go. Now, if we press this thing, press it down, and you can see it only sends it once. This ensures that we don't keep sending that master warning without any necessity. So yeah, as we can see, we can already send the command to turn the button off. Most importantly, we also want to turn the light on. So here we go with the warning LED. We already defined it's an output. So we need to retrieve somehow that light is on. So we're going to use the connector .data handling. Now what does data handling do? It just listens. It listens to the serial port. If the connector receives a new variable, so let's say master warning on, it receives that, it sends it over serial towards our Arduino. Our Arduino notices, hey, new data came in. It looks, how is this data formatted? What is the prefix? And deducts that way what it needs to do. It then takes its variable, stores it in the library. Connecting the data handling, just make sure that that process keeps running every time you run the loop. So if new data comes in, it gets stored. The only thing that we need to do is retrieve the data. So we say Boolean, because it's a true or false state. If the light is on, if the light is off. Bool, warning lights on is connector dot get master warning on. Something like this. Gonna see get master warning on. It's actually the right one. Now for some reason it tells me that this is wrong, but it isn't. So it could be send master warning. Here we go. And it should fix itself all the time. Doesn't matter. It worked before, and so it should work now. So this works right now. If it's true or false, it will set the Boolean to true or false. The only thing that's left is to combine this with an action. So I'm going to say if warning light on. Now why does this work? If, and everything that's between the brackets is going to be a true or false statement. So right here we have if milliseconds is equal to 0, if it's true or if it's false. Here it's the same thing, if the milliseconds since press is bigger than 250. If it's true, do this. So it's always a true or false statement that's in between here. And this is a Boolean, so it's always going to be true or false. So if it's true, if warning light is on, we say digital write, and we take the warning LED. And what are we going to write? We want to write that it's high. So high means power runs through it, or basically high means the signal is high active. A signal gets sent, in this case 5 volts gets sent over towards the resistor, from the resistor towards the LED, turn the light on. Here we go. So if it's not true, so if the one light's not on, so else, we'll say digital write, warning LED, and the opposite of high is going to be low. Here we go. Now, last thing left is to test this out. Make sure to close the serial monitor, or else it won't work. Here we go. Here we've got the Bits and Rods flight connector. You need to have the latest version for this to work. Go to outputs. I got it in my gear setup, so gear, or whatever you want to do. You can create, first you have to enter a name. So let's create a new one actually. New warning video. Save set. It comes up here. Nothing in here yet, so we go to warnings. I've got some things pre-selected, doesn't matter. You select the master caution, master warning, hit save edits. Here we go. And this is the Arduino Leonardo at 19. We need to restart it actually. I'm still working on that bug, sorry. So once we restarted it, we take the Arduino Leonardo, new warning video. So I gotta stick with my traditions, and if I test something, I want to be flying from Amsterdam. So when I'm flying, I want to fly from Amsterdam, or I'm testing things. So if you see me parked here, you know that I'm testing things. Right now I've got players turned off because I want to start from the runway to make sure, I don't know, if I start at TBM 930 sometimes from a cold and dark state, I can't get it to start properly. I need to go into the runway or reload it through the little dev modes for it to work. So that's why we're just going to be going straight for the runway, players turned off. Now the easiest way to test it in this plane to see if it works is to, well, for the caution, we can turn off the pitted heat, intermediate trigger, and for the caution warning, we can just press the close the fuel selector. And here we go. If you press it, it turns off. Turn on, and we see that we have a pressed in state. So here we go. Press it again, and it turns off again. So that's all there is to it. We got a button that triggers for the master caution and master warning. You can trigger any command you want with it, and we can send the command to the game. You can add one of these buttons, you can add 10 of these buttons, you can do whatever you want. And it's a relatively low cost solution for something like this. Now this update has been available to my Patreon supporters as an early access, so if you're interested in that, go check it out in the link in the description. For the rest of you that want to support me, hit the subscribe button or the like button, and it would really help me out, and I'm very grateful for all who did. Thank you very much, and most importantly, I hope to see you in the next one.